Okay, so today we'll be discussing some more complicated ellipse questions on the ACT. But before we can move on to these questions, it's really important for us to understand and memorize the formula of an ellipse, which is given right here. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, and it's really important to memorize that h and k are the center of ellipse. Written at right here. The center is going to be h comma k. The horizontal stretch, or a squared, is going to simply be the stretch of the ellipse along the x-axis starting from the center. And b squared similarly is simply going to be the stretch of the ellipse along the y-axis or the vertical axis starting from the center. Now let's move on to some more challenging ellipse questions. Okay, let's move on to question 58. One of the following equations determines the graph in the standard xy coordinate plane below. Which one? Okay, so first off, I'd recommend drawing out the center. So we could see that the center is about 3, 4, I would say. 3, 4. Okay. So let's write that out using our ellipse equation. So it'd be x minus 3 squared plus y minus 4 squared equals 1. And we could figure out the stretches soon. Okay, so first, let's just take a look at the answer choices to see if we can eliminate any answers just off the bat. So we can see that we can eliminate G because the centers don't match. And we can eliminate J and K as well since the centers do not match. Now let's find out what the stretches are for these ellipses. Let's start off with the horizontal stretch. So if we see here, we can see that the edge of this ellipse is about right here at 8. Okay, so let's figure out what the horizontal stretch is. So if we're starting off at 3, which is our center, and we're moving on to 8, how much is the ellipse stretching? I would argue it's stretching 5 here, from 3 to 8, because 3 plus 5 equals 8. So we could write down right here 5. Okay, let's see. So we could automatically eliminate h simply because we know that the a squared value does not match as well because the a squared value here is 5 squared and 5 squared equals 25. So we can land on F. But we can also finish out solving this ellipse equation to make sure that we really understand how ellipses work. So I'd say let's write down what we have so far. X minus 3 squared over, let's see, what is 5 squared? 5 squared is 25 plus y minus 4 squared over something b squared equals 1. Now let's figure out what the vertical stretch is. So starting from the center of the ellipse, once again, starting from 3, let's see where's the topmost edge of the vertical most edge, I guess I could say, of the ellipse. So I would say that the vertical most edge is around right here. I'd say near 6 or so, because as you can see, this diagram isn't great given by the ACT, but it's near 6. And so what would be the stretch from 3, the center, or the center 4, to about, I'd say it's more like 7. So what would be the stretch from 4 to 7? Well, I would say that from 4 to 7, it would be 3, right? Because if we see right here, the topmost is landing at about 7, and the y value of the center is 4. So from 4 to 3 is 7. So we could write down 3 right here, and 3 squared leaves us with 9, and that checks out right here with x minus 3 squared over 25 plus y minus 4 squared over 9 equals 1. See, h would have been a tricky option because essentially h is just the flipped version. H flipped around a squared and b squared. So that's why it's really important to make sure to actually solve out the full equation, or at least the most part of the equation, in order to figure it out. Let's move on to another question. 56. Shown below is a quadrilateral ABCD inscribed in an ellipse. The figure will be placed in the standard xy coordinate plane, and the ellipse will be described by the equation x squared over 9 plus y minus 5 squared over 16 equals 1. Given that AC is the minor axis and BD is the major axis of the ellipse, what will be the coordinates of A and B? Okay, so what will be this and this coordinates? Okay, so if we go back to our original ellipse equation, right, we write out x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, so here it's given us the center. We see that the center is going to be 0, 5, because if we look right here, we see that 5 is the k value. And since there's nothing on the x value, since there's nothing in parentheses or nothing relating to this x value right here, it's just 0. So for example, like this would just be, in this situation, it would be x minus 0 squared, right? But, or in this case, it would just be x. If there's nothing next to the x value, just assume that it's going to be 0. Whereas here we could see that obviously 5 is the k value. So let's just write down our center right here. 0, 5. Okay. And it also tells us our stretch. So we're given that a squared equals 9 and b squared equals 16. And the reason that we know that is we could just simply cross-check with our equation. We wrote the standard equation right here. We could see that underneath the x values, a squared's there, and a squared's 9, and then we could just cross-check b squared's right there, and that's 16. Okay, so let's solve out for a and b real quick. So we would get a equals 3, b equals 4. Okay, now let's find out the values of a and b on this plane, A and B. Okay, so since we know that A is going to be 3, that means that A is stretching 3 from this side and this side, right? So our main point of concern is A right here. So we know that A is stretching 3 right here, right? We know that this is going to be 3 right there. And so we know that A has to be negative 3, 5, because think about it, right? So we know it's going to be 5 simply because nothing on the y value changes. But it's going to be 3 since it's going 3 to the left. And here, if you start from 0 and you go 3 to the left, you end up at negative 3, which is the a value right here. So it would be negative 3, 5. Here, let me write this neater. Negative 3, 5. Okay, now let's see the b value, which is vertical. So we know that it shifts vertically 4 just because we solved out for this value right here. So we know from here, from the center up, it shifts vertically 4. That means it goes from here to here, 4. Okay. So now, essentially, all we have to do is what's 5 plus 4. And the reason we do 5 plus 4 is because 5 is the y value, and since it's shifting vertically 4, since it's stretching vertically 4. Sorry, this is stretching, not shifting. Since it's stretching vertically 4, we know that 5 plus 4, this must be 0, 9. The reason it would be 0 is because nothing on the x-axis actually changes. You can think of it like a coordinate plane almost. For this diagram, right? If this is 0, 5 right here, and we move 3 to the left, this would be negative 3, 5. And if we move up 4, this would be 0, 9 right here. You could think about it like that in sense of a coordinate plane. And so if we match up our answers, where we see point A is negative 3, 5, A negative 3, 5, B 0, 9. Let's see if any of our answers match up. And sure enough, option J matches up with point A being negative 3, 5 and B being 0, 9. So as I said, the easiest way to think about this is once you've done all the solving to figure out the stretching horizontally and vertically, just think about it like a coordinate plane. If we know that the center is going to be 0, comma 5, you could just simply sketch it out right here. Say that this right here is 0, comma 5, and you move left 3, that's going to be negative 3, comma 5, and if you move up 4, that's going to be 0, comma 9.